Okay, so are you ready to dive into a topic that's like surprisingly fascinating? We're talking temperature today.
And get this,
Yeah.
our source material is a sixth grade science textbook.
It's amazing how much we can learn from going back to basics.
Right.
I mean, we often just take for granted all this stuff we think we learned in school, but I have a feeling this deep dive is going to uncover some like hidden depths behind something we encounter every single day, temperature.
It's definitely more than just a number on a thermometer.
Totally. And speaking of thermometers, this textbook kicks things off with a story about these siblings in Shillong, India, Lambuk and Fibbin. So Lambuk's feeling a bit under the weather, thinks he might have a fever, and Fibbin, being the caring sister she is, reaches out to feel his forehead.
Hmm.
Pretty standard stuff, right?
Yeah, it's like our instinct to rely on touch to figure out how warm someone is. But can we really trust our sense of touch to give us an accurate reading?
Ooh, that's a good question. I mean, we do it all the time, but now that you mention it.
Yeah. Well, the textbook uses this simple experiment to illustrate the point. You've probably even tried it yourself. 3 bowls of water, one warm, one at room temperature, and one cold.
Oh, yeah, I remember this.
So you dip one hand in the warm water and the other in the cold, wait a bit, and then plunge both into the room temperature water.
Okay.
And here's where things get interesting. The hand that was in the warm water will actually feel cold in the room temperature water. And the hand that was in the cold water, it'll feel strangely warm.
It's such a weird sensation.
It is, but it shows how our sense of touch is relative, not absolute. Our hands are comparing temperatures, not objectively measuring them.
Which brings us right back to Lambach and Fian. Imagine if Fiban had relied just on her sense of touch. Would she have urged Lambach to stay home from school? Would she have even thought to grab the thermometer?
It's an interesting thought, isn't it? This simple anecdote shows why having a reliable way to measure temperature is so important. We can't just trust our senses. We need something more objective, more accurate. And that's where thermometers come in.
Okay, so thermometers, they're like the heroes of temperature measurement, right? But there are different kinds, aren't there? I know the textbook mentions clinical thermometers and laboratory thermometers.
Right, and it's pretty easy to figure out what makes them different. Clinical thermometers are the ones we use for healthcare, specifically for checking someone's temperature. But lab thermometers need to handle a wider range of temperatures, so you'll see them used in experiments and stuff like that.
Okay, that makes sense. So no matter what type of thermometer we're using, they all need a scale to tell us the temperature, right? I mean, how hot or cold something actually is.
Exactly. And the textbook focuses on Celsius for this, which is pretty standard for science these days. You're probably more used to hearing Fahrenheit, but in the science world, Celsius is what they use.
Yeah, that's good to know. It makes you think, though, back in the day when everyone was using those old mercury thermometers, how reliable were the readings, really? Weren't those things known for being kind of finicky?
You're right about that. The textbook actually mentions how mercury thermometers are being phased out and replaced with digital ones. And it's not just about safety, even though that's a big part of it since mercury is toxic. Digital thermometers are also way faster and easier to read.
Oh, yeah, for sure. Remember how long it took to get a reading with those mercury thermometers? You'd be standing there forever waiting for that little silver line to move up.
Exactly. And imagine if Fifiban had been using one of those old mercury thermometers on Lambuk. Do you think she would have waited long enough to get an accurate reading? Or would she have just gotten impatient and said, okay, you're warm enough, stay home?
That's a really good point. It makes you realize that even something as simple as switching to a digital thermometer can have a ripple effect. I mean, faster readings mean quicker diagnoses, which could mean getting the right treatment sooner.
Absolutely. Technology having a real impact on healthcare. Now, once you do have that accurate reading, it makes you wonder what actually is a normal body temperature anyway.
That's so true. I feel like we always hear that 37 degrees Celsius or 98.6 Fahrenheit is the magic number.
Mm-hmm.
But the textbook actually says that's more of an average than a hard and fast rule.
Yeah, you're right. Body temperature changes depending on all sorts of things, like your age, the time of day, how active you've been. It's constantly going up and down.
That's pretty wild.
Yeah.
It makes me want to carry a thermometer around all day and just check it constantly to see how much it changes. Speaking of variation, though, I thought it was interesting that the textbook mentioned how little kids often have slightly higher temperatures than adults. Why do you think that is?
It's definitely an interesting question. What are your thoughts?
I don't know. Maybe it has something to do with their metabolism being faster. Or maybe it's because they're constantly running around and using up more energy.
Those are great guesses. It could be a combination of factors. We'll have to look into that more. But for now, let's switch gears a bit from talking about our internal temperatures and talk about the temperature of the world around us.
Oh yeah, good idea. We've been totally focused on bodies this whole time. The textbook does talk about air temperature, though, and how important it is for stuff like weather forecasting.
Exactly. Air temperature is like the foundation of weather. It affects everything from whether we'll have sunshine or snowstorms.
Which is why it's always the first thing they tell you in the weather report.
Yeah.
Right? It sets the stage for the whole forecast.
Yeah.
Yeah. You know, I can't imagine trying to plan a picnic without knowing if I need sunscreen or a sweater.
Exactly. But speaking of interesting things, the textbook also mentions this woman, Anna Manny, and all the work she did in meteorology. Have you heard of her?
Anna Manny. The name rings a bell, but I can't say I know much about her.
Well, she was known as the Weather Woman of India. She was an amazing scientist. She developed a ton of weather instruments, but she also was a huge advocate for renewable energy in India.
Wow, that's incredible. I love that we're getting a little history lesson along with our temperature deep dive.
It just goes to show you that even something as basic as temperature has all these fascinating stories and connections.
For sure. Okay, so we've talked about body temperature and the air around us. But I know the textbook also mentions some pretty extreme temperatures, like when water boils or freezes. It stays at the same temperature, right? That always kind of messes with my head.
Yeah, it's true. We call those phase changes. You know, when something goes from one state of matter to another, like from liquid to gas or liquid to solid. And during those changes, the temperature stays constant. It seems weird, but it's because all the energy is going into changing the state, not making it hotter.
It's so bizarre to think about.
Yeah.
And then even more extreme, you have this idea of absolute zero, which the textbook touched on briefly. That's like the ultimate coldness, right?
Exactly. Absolute zero. It's negative 273.15 degrees Celsius, or 0 Kelvin if you're using that scale. It's the absolute lowest temperature possible. Like, theoretically, it's where all atomic motion would stop. Can you imagine contrasting that with the insane heat at the core of the sun?
Whoa. Talk about a temperature difference. It really puts things into perspective.
Doesn't it? And speaking of perspective, remember how we were talking about how body temperature can be different for everyone? Well, it's kind of like that with planets, too.
Oh, yeah, because of how close they are to the sun.
Right. But it's not always as simple as that. Like, closer to the sun means hotter. There are some weird planets out there. Planets with really unique conditions, so their temperatures are totally unexpected.
Ooh, okay, now I'm really curious. What are these planets that break the rules?
You'll have to do a little research on your own for that one. That's where I'll leave you. The textbook actually encourages everyone to go and see if you can find those planets with those strange temperatures and then try to figure out what's causing them.
I love that. A little homework assignment to keep us thinking. And to think this all started with a 6th grade science textbook.
It just shows that you never know where curiosity will lead you. Even something as simple as temperature can be a gateway to a whole world of questions and discoveries. It's not just about memorizing facts, it's about looking at the world around us with a sense of wonder.
I love that. So to everyone listening, the next time you check the weather or grab a thermometer or just feel the warmth of the sun, take a second to appreciate the amazing science behind it all. Until next time, stay curious.